Hey, so the purpose of this video is to demonstrate how to automate a self-hosted integration runtime for Azure Data Factory using all secure infrastructure. So to give you a little bit of background, Azure Data Factory, if I pull it up right here, you can have a self-hosted integration runtime in here. But creating this process manually takes a lot of work, and having this automated in infrastructure as code makes it more usable and easy to promote to higher environments. So here I'm going to show you how we're going to automate this using Terraform. Here's kind of a workflow diagram of what's going to happen. We're going to be using Azure DevOps to run our Terraform code. And this is going to create this resource group over here. It's going to create an Azure Data Factory. It's going to create a secure VNet for everything in here. And by secure, I mean there's going to be no public access permitted on this virtual network. Then it will create a self-hosted integration runtime, a virtual machine, and then it will create a storage account. The purpose of the storage account is to upload the script for installing the self-hosted integration runtime on this VM. And all of this happens in secure lockdown networks. This VM will have access to this secure virtual network through private endpoints. Everything will be locked down with private endpoints and private network access. So give you a rundown of kind of what this looks like. Here's a resource group that I created with all of these resources built in. So you can see we have the Azure Data Factory. We have a virtual network. And here in this virtual network, it is a lockdown private network. If you can see, in our network settings, we have two private endpoints, one blob and one data DFS, and this is for our storage account to connect to our virtual network privately. That gives you a rundown of our virtual network here. Then going back to our resource group, you can see our data factory is loaded up in here. We have made two private DNS zones, blob core and DFS core. We have made this virtual machine to host the self-hosted integration runtime. And then we have the storage account to store our self-hosted integration runtime script. If you look at the storage account in the networking section, only access from selected virtual IP access is allowed, and no virtual networks are listed here. But the storage account has two private endpoints to our virtual network, and that's how it's able to securely, privately connect to all the other resources in our network. And within our containers, you can see right here, so they are private level access. And here's where we store our SHRS script. And you can see I can't actually access this right now because it's locked down on private and I have not enabled RBAC access for my account. But that's not needed right now for me to demonstrate how to install this. You can see right here in our Azure Data Factory, we have a self-hosted integration runtime. It is currently running. And this was all done through Terraform automatically. Now I'm going to walk through some of the Terraform code to set up this resource group, storage account, and everything within it. So we start off with our main.tf file, which is using a remote backend with a specific specific key file, state file. And here we have our Azure Data Factory, very basic Azure Data Factory. And then we've created a self-hosted integration runtime within this data factory. The purpose of this is to grab the SHIR key and ID. Then you can see our network over here. We have a simple virtual network with one default subnet and one subnet for all of our private endpoints. This is where our storage account is going to be located. This is all in one resource group here that we have a random string as a suffix. Here is our storage account, our private storage account. We've set this up here as a storage v2 account. And you can see here, we've set up a container for the script. Container access is private. And then within this blob code, we're uploading our SHIR script into this container right here. And then you can also see right here within our storage account network rules, our default action is deny. So this is a private lockdown storage account. And then within that, we have also set up 2 DNS zones for this storage account to privately connect, and DNS links for those DNS zones. And then we create these DNS A records for that storage account over here. One private endpoint for blob and one private endpoint for DNS, and then the corresponding A records to match. And lastly, we have our virtual machine. First, we create a network interface that has access to our private endpoint subnet. This way, the virtual network interface on the virtual machine can access our private network. Here we have a virtual machine. This is not secure passwords. If you are making this on your own, I would recommend storing these passwords in a key vault. But for demonstration purposes, they're included here in plain text. So we've created this virtual machine, SHIR, and then the magic happens here in this virtual machine extension. So this is a custom script extension, which is installed on this virtual machine. And what it does, it goes to that storage account, goes to that blob of that storage account, downloads that file, and executes the self-hosted integration runtime script. And then we have certain parameters on the script that we give it a certain gateway. This gateway key is the self-hosted integration runtime that we made in this file over here. An output of this resource is a gateway key, and that is what we have included in our parameters here for this integration runtime script. And then we also give it the storage account key to access the storage account to download this file. And that's all here within the protected settings of this virtual machine extension. And I can quickly run through the actual self-host integration runtime script. One parameter is the gateway key that we put in over there. And then from this point onwards, it just downloads integration runtime, connects to a specific data factory, and then creates this data factory as well. All this code will be included in the blog post and the wiki that is included with this video. Okay, so that's a quick rundown of all of our Terraform code. Now I'm going to show you us running this Terraform code and actually creating these resources all automatically. Now, one thing to mention before I run this is that because this is a private lockdown storage account and private network, our Terraform code will work fine on the first run, but on any subsequent additional runs are if we're using Azure DevOps to run Terraform, Azure DevOps runs Terraform on their public Ubuntu agents. Those public agents will not have access to a private VNet. But when first creating the private VNet, these public agents will have access to all the resources. But on any subsequent runs, you will have to use a self-hosted agent that has connectivity to this private VNet in order to run any further Terraform runs. But on our first run, we don't need that. So here I've set up a very simple Azure DevOps pipeline. All it does, it runs on an Ubuntu pool, public Ubuntu pool. It initializes Terraform to the specific directory that we were in. It runs a Terraform plan, and then it runs a Terraform apply. And I'm going to run this and then create our resource group. So now our Terraform deployment has been completed. I can walk through a little bit of it right now. It said it was going to create a data factory, then the integration runtime. The main thing I want to look at is extension and the storage account blob. Here are the private endpoints that were going to be created. Here's the storage account. Then we have the storage account network rules with deny. Here's the blob with this self-hosted integration PowerShell script. Perfect. And then is the script extension right here. Virtual machine script extension right here, known as ADF SHIR. And you can see everything was created. The extension takes the longest to create. Took about 7-ish minutes, 7 to 8 minutes, just for the extension to be created. Full deployment took around 11 minutes, 11 minutes and 41 seconds. So you can see right here, it tells me that the resource group that was created, SHIRPOCITVH. Now if I go to my Azure subscription, refresh, I see ITVH over here. And I can see Data Factory was created, VM was created, private endpoints and blob, storage account was created. Let me see, storage account. Container was made. Perfect. Container was made, exactly what I needed. Then, so I go to the Data Factory, the moment of truth. We should see our self-hosted integration runtime already in there, and it should be running. Go to manage and we click on integration runtimes. Here we see our self-hosted integration runtime is here, and status it's running and it's working. So this was a successful deployment, and this is how you securely automate a self-hosted integration runtime for Azure Data Factory using Terraform.